We're moving on to the next video of our new lesson part, and what I want to start with is tough questions from last night's homework. So on Thursday, I put up a video. I gave you guys an assignment. It was due Monday morning at 10 a.m. And from the looks of it, you guys did a really nice job on it. I always look at what your answers are when you submit into that link, and a lot of you got a lot of the questions right, so I was really happy to see that. What I want to do is go through numbers 7 and 10 from that homework, which I consider two of the tougher ones. Talk them through before we do our new notes for today. So let's look at number 7 here. This was again from the homework assignment. It said, which is not a solution to 2 to the t equals radical 10. All right. So what I was going to do first is rewrite this with logs. Right. So I'm going to rewrite it down here. 2 to the t equals radical 10. So I'm going to log it, right? And there's two ways of logging it. One is to rewrite it as log, right? What would the base be? 2 radical 10 would go there equals t. Now, if you notice, that's choice B. So it says which one is not a solution. So I'm going to cross that off because it is the solution. Right? Now, then I'm going to look at these. I'm like, how in the world do they get these from this? And what I said to myself is, well, if I got a handy-dandy calculator, right, why am I going to torture myself with this? I'm going to put the decimal points in. So, turn my calculator on. All right, let me see how close I can get so you guys can see. What I'm going to do is type in the original, right, this guy right here, and see what we get as a decimal. So I hit math, go up twice. I got log, and I put 2, and in the parentheses put the radical 10. So I'm getting 1, so I'm going to write it 1.660964047 equals t. Now, I'm going to go through and put the rest of these in my calculator, and the one that doesn't give me the same decimal, that's the one that's not equal. So the first one, do my alpha y equals, I'm going to put in 1/2. I'm going to hit my math button, go up to the log base, type in log 2, and then 10. I got the exact same decimal, so that means that can't be it. So I'm going to cross that off. Now, log 410, I'm going to put that in. So math, go up twice, put a 4 there, then a 10. Oh, exact same decimal, so I'm going to cross that off. And finally, put the last one in. You already know this is the answer, but see how the decimal is different? So that is not equivalent. So that was by far the easiest way to do that question. All right, now let's look at number 10. Now, in order to do number 10, we're trying to solve for x. So what you should have done first is divide by 8. So I get 2 to the x plus 3 equals 6. Now I'm going to log it. So I'm going to do log 2 to the x plus 3 equals log 6. Okay. Now, the exponents always fall in front. So now there's two pieces. So I'm going to put that in parentheses. X plus 3 log 2 equals log 6. Okay. Now I'm going to divide by log 2. Right, so that cancels. X plus 3 would make log 6 over log 2, right? Then I'm going to subtract the 3 over. Right? So that is the answer that I got. Voila. Okay, so that was number 10. So that should have been the work you did. Now, what we're going to do today, since you guys seem to have a good grasp of what that was, is we're going to work on word problems. So I attached onto Google Classroom a packet. It's the Exponential and the Logarithmic Word Problems packet. So what you guys should do, if you can, your best bet would be to print that packet out. If you can't print it out, then you should write down all these words. Right, so at this point, pause me And if not, or pause me and print it out. Pick your two options. And then we're going to do this in a second. All right. So I hope you either wrote down the question or you printed out the packet. It's a little easier if you print out the packet. But let's take a look at the first question. It says, the moose population in a wildlife refuge is modeled by the formula m equals 125, 1.03 raised to the t, where m represents the number of moose t years since 2012. Okay, how many moose were in the refuge in 2012? So 2012 is when this started. So anytime they want you to figure out at the beginning of something, that would be time 0. So I'm going to go to my equation and plug 0 in for t. So I'm going to do m equals 125, 1 plus 0.3 to the 0. I'm going to grab my calculator. 125, 1.03 raised to the 0. And look what I got, 125. So how many moose were in the refuge in 2012? 125 moose. Now, does that 125 look familiar to you? Where have you seen it before? I'm hoping you realize it was the number in front of the parenthesis. And that's not a coincidence. That will always happen. This number here will always be the original amount or the starting amount. So anytime, you don't even have to show this work. If you can just look at it and go, hey, 125, you could just write that down as an answer. All right, let's look at B. Is the moose population increasing or decreasing? How do we know? Well, let's go back to my equation. This equation tells me a lot. This equation is part of what I call the percent increase / decrease formula. So I want you guys to write this formula down, right? The percent increase decrease formula is always going to be A equals, let's see, we're going to do A sub 0, 1 plus minus R to the T. So percent increase decrease is A equals A sub 0, parentheses, 1 plus minus R to the T. Let's talk about what this means. A is going to be the amount. So A equals amount. Right? A sub 0 means original amount. And if you notice, what was the, see how it's A sub 0 is right in front of the parenthesis? What was the original amount of moose? 125. Okay. We're going to talk about this in a minute. R is the rate, and T equals time. So that's worth writing down. That's an important formula. So the plus minus tells me whether something's increasing or decreasing. And you see the number 1? That's the key. Look at this parenthesis. Is this number bigger than 1 or smaller than 1? And I'm hoping you're saying bigger than 1, right? That means we added on the rate. That means it's going to be an increasing function. So is the moose population increasing or decreasing? It is increasing. Right? And you always have to explain why. Because 1.03 is greater than 1. So anytime your number is bigger than 1, it's going to be increasing. All right, so increasing answered that part of the question. How do you know? That's how we knew. Okay. How many moose, to the nearest moose, will be in the refuge in 2015? Okay, so let's take a look at this for a minute. 2015, what year is this all based on? 2012. Okay, how many years later is that? 3 years later. So that means they want us to plug in T equals 3. So I take my equation, M is 125, 1.03, and we're going to raise it to the 3. So we're doing 125, 1.03 raised to the 0.0875. So that's what my calculator just told me. But if you notice, it says to the nearest moose. So let's take a look at this. Right? You have to round to the nearest moose. So 136.5 would round to be approximately 137 moose. Okay, now what I want you guys to notice is, see how this number is bigger than 125? That confirms it's an increasing function, so it should make sense. Now, what I'd like to figure out is, what is the rate? What is the rate of increase? We know it's increasing. And the way you figure it out is, how far away is 1.03 from 1? So all you have to do is subtract your base, right, the number in the parentheses, from 1, and we get 0.03. That means the rate would equal 3%. And that's how you're always going to find the rate. We're going to practice a lot of these. Okay, let's look at D now. How many moose to the nearest moose will be in the refuge in the year 2020? So I want to know how many are in there now, right? How many years after 2012 is 2020? We said 8 years later. So now we're going to plug in 8. So I've got n equals 125, 1.03 to the 8. Now I'm going to go to my calculator and type that in. 125, 1.03 raised to the 8. And I'm getting 158.362602. All right. But once again, it wants it to the nearest moose. So I'm going to round. So 158.3, right? 0.3 means we're going to leave it 158 moose. Okay, next one. How many moose to the nearest moose were in the refuge in 2010? Okay, what year was this equation based on? 2012. Well, there it is, 2012. How many years before 2012 is this? 2 years before. So that means you're going to plug in t equals -2. We want 2 years before. So now we do m equals 125, 1.03 to the -2. 125, 1.03 raised to the -2. 117.82448886. All right, and then once again, 117.8, that's going to round to be 118 moose. Okay. I hope you're with me. These aren't so bad. Maybe the beginning was a little new, but most of it's plugging in the calculator. Okay, one final one. How many years to the nearest tenth of a year will the moose population be 500? So this question's a little different. I want to know when we'll have 500 moose. So I'm going to write down the original equation again. Okay, it says how many years? Years is time. So this time I want to know time, and I'm telling you we have 500 moose. So in this one, m is going to be 500. We get 125, 1.03 to the t. And now we're going to solve this guy. All right, this was like the homework you guys did over the weekend. You're going to divide both sides by 125. Okay, so on my calculator, 500 divided by 125, 4. Right, so I'm going to bring it over here. I have 4 equals 1.03 to the t. Okay, now 2 ways of doing it. You could log it, or you can write it as a log. Log 1.034 equals t, right? That's probably the easiest way to do it. So I'm going to do math, log 1.03, and then I'm going to put a 4 there. I'm just going to double check. Yep. Enter. Okay, and then it says to the nearest tenth. So I'm going to go 1 decimal point place. So it's going to be 46.9 years equals t. Okay. So that's our first question. We're going to do one more of these. Okay, and this one's going to be about a car. All right, number 2. The value of your car is modeled by the function v of t equals 2,000.87 to the t, where v of t is the value of the car after t years. How much is your car currently worth? All right, so that means I want to know how much it's worth right now. And you should be able to figure that out without doing any math. What would be the original amount of the car right now? And look, it's always going to be this number right here in front of the parenthesis, 2,000, right? So it's going to be worth $2,000 since we're talking about money, value. Okay, now, if you didn't trust yourself to do it that way, you can always get it by doing 2,000.87 to the 0, because that's currently, and if you put that in your calculator, you'll get 2,000. But you do not have to do this if you remember it's always the number in front of the parenthesis. Okay, so that's the answer to the first one. Okay, is your car increasing or decreasing? How do we know? All right, how did we figure that out last time? Where did I tell you where to look? Okay, we're always looking to the number in the parenthesis. Is this number bigger than 1 or smaller than 1? It's smaller than 1. So that means it's decreasing, right? Because, and you always want to tell me why, because 0.87 is less than 1. And if you don't want to use the symbols, you can use the words. 0.87 is less than 1. So that counts 2. All right, now, before we go on to the next one, I want to know what's the rate. Okay, do you guys remember how I got the rate in the last one? I just need to know. You're going to subtract. You're going to do 1 minus 0.87. Now the last one I did, let's see if I can pull it back up. You go back to this one. All right, you always do the bigger of the two numbers first. So in this one, since 1.03 is bigger, I did 1.03 minus 1. But in this question, which is bigger, 0.87 or 1? 1 is. So I go to my calculator, and I do 1 minus 0.87, and it's 0.13. Okay? What would that be as a percent? Good, 13%. So that's what the rate would be. All right, a couple more questions. How much will your car be worth in 5 years? How would I figure that out? Wait, that's my equation up there. Well, 5 years, years is time. That means you're going to plug 5 in for t. So I'm going to do 2,000.87 to the 5. Now, this is how much is your car worth. So our answer is going to be money. So I'm going to type in 2,000.87 raised to the 5. Right? Now it's money. So how many decimal point places do we go to for money? Hope you're thinking 2. So it's going to be $996.84. Okay. How much was your car worth 3 years ago? Ago means back in time, so that means you're going to plug in -3, back in time. So we're going to do 2,000.87 to the -3. Okay, and go to my calculator. Now again, it's money, so we're always going to round to the nearest cent. I'm getting, let's see here, move this. $3,037.19. Okay, and the last one. And how many years to the nearest hundredth of a year will the car be worth $400? Now, how many years means we don't know time. So let's write down our equation again. It's V of t is 2000.87 to the t. See how it says worth 400? That's its value. So the 400 is going to go there, and we want to find t. Okay, now what would I do first to solve this question? Divide by 2000. They both cancel. So this is 0.87 to the t equals 400 divided by 2000. 0.2. Now I'm going to solve this two ways. Option 1, which I think everybody likes better. I'm going to rewrite this as a log. So it's log 0.87, 0.2 equals t. Right? I go to my calculator. I'm going to math, scroll up. Log 0.87, 0.2. And I'm getting, now they want it to the nearest hundredth, that's 2 decimal point places. So it's going to be 11.56. It's going to round to. And that would be years. Okay, so that's one way of doing it. Option 2, right? I'm going to take this equation and log both sides. Right? And when you log it, where does that t fall? In front. Okay. And then I'm going to divide both sides. Log 0.87. So t equals, and we should get the exact same answer. Ready? Log 0.2, log 0.87, and voila, 11.56. All right, so it doesn't matter if they both give you the same answer. So you guys are going to try some of these for me. There's a worksheet up on Google Classroom, and there's a link for you to enter just like normal, and we'll see how